So let us take more questions where we have more than two bodies. We have three bodies. That might be a little interesting. So there I am not going to explain you by all the methods. You do it for yourself, and I'll pick any two methods of my choosing and do it. So this is your first case of three bodies. So let us call this as body 1, this is body 2, this is body 3. Now what you can note over here is, unless until I know the movement of two bodies, I don't know how much will the third body will move. Say this body number 2 was, or body number 3, that's the easiest to imagine, that body number 3 was stationary and I move this body number 1. So if this body number 3 is stationary and moving this body number 1, body number 2 is going to go with a certain velocity, with depending on what's the velocity of body number 1. Now suppose I let the body number 3 go up or go down. So I am moving body number 3. In fact, let me make this stationary and make body number 3 go down. So this is going to go up by a certain velocity, and we have done a lot earlier, so we know if we move 2x down, it's going to go x up only, and vice versa. If I move it 2x up, it is going to go x down. But if both are moving, then there will be some other movement. That means I need to know the velocities or movement of two bodies to get the movement of the third body. And it is, if you feel that this goes up, then this should go down. No, not necessary at all. So let me do this. Like this goes up with 3 meters per second, and this also goes up with 4 meters per second. Why and all? Maybe there was some force on this body and this body was being pulled the other side, so both were going up. We are going to do constraints. If these were the movements due to whatever reason, then what is the movement of this, provided all the string is tight? It is different from a situation where I say that all has been let go, they have some masses, and then how they move. Then maybe this was moving down, that was moving up, or maybe this was also moving down and this was going that way. So that's a different, doing laws of motion and solving your forces. By the way, can there be any situation such that nothing moves, everything is frictionless? This is a very, very massive body, say 1000 kgs, and everything is frictionless. Will there be a situation where nothing moves? No, there won't be. Due to the weight of this body or this body, this string has to have a tension. If this string is having a tension, it is going to pull this body, how much ever low force it is. Even if it is 1 gram force tension in this, it is going to pull the body and will create an acceleration accordingly by the formula F is equal to ma, provided there is no friction. So practically it is possible, because practically no friction is very difficult to achieve. Okay, getting back to the situation, and say I've written the numbers 3 and 4 and I want to know the velocity of the body. So what will be the velocity of the body? So according to this, intuition says the body will be moving that way. Now let me do it, my old method or my first method of analysis. So I am inclined to move the movable pulley first, and everything is at their own place. So if I move the movable pulley up by 3 amount, so 3 is given, so if I move it up by 3 amount in a second, so we'll have 3 loose here and 3 loose there, 3 and 3 loose. So what we have got is 6 loose. We have not moved this yet. So to tighten this, I'll pull this by 6, so that the 3 here and the 3 here gets tightened. So I'm pulling this by 6, so I've got amount of 6, but this has not moved. That's a situation when this was going up by 3 and this was stationary. Now this has become stationary. The one which I have moved up by 3, now it is stationary over there. It is stationary over there. I have tightened these loose strings by pulling 6 on the other side. So now this, I'm moving the body number 3 now with 4 movement up, 4 meters in a second up. So I have moved it 4 up. So what happens? This is stationary. So the whole string is stationary. So this is stationary, stationary, stationary pulley. So if I move this up by 4, this part will go down by 4. If this part goes down by 4, this string is going to go up by 4, and hence this string has to be pulled by 4 more. So what do I get is 6 plus 4, which is equal to 10. So I guess the answer is 10 meter per second is with which this body will be going that side. Who is making it go is another story. There might be some force over there which is making it go that side. If you let go, it is just going to go down. So that's your method 1, and we get your velocity of this end is 10 meters per second. I would have rather taken just variables and explained how the variables are related, but let's do this by the next method also. So what is that? You have to write the increase and decrease in the string length. So going from this side to this side. So how much this reduces by? This section reduces by 4. So I'll write what? I'll write minus 4. is how much this reduces. How much is this going to reduce by? This pulley is known that it has come up by 3. I don't care what has happened to the string and where it should go, because there is some other force which is governing everything. This pulley has come up by 3. So this section of the string has reduced by 3. So I'll have a minus 3 again over here. And what about this section of the string? That section has also reduced by 3 because the pulley has ultimately come up by 3. So this pulley has come up by 3. This section length has again reduced by 3. So minus 3 over there. And this section has increased by a certain amount, unknown amount, by a V amount. So it has gone by V. So this section has increased by V. So I put plus V over there. And total increase or reduction should be equal to 0. So that is what I put. And we get V is equal to 10 again. So that's your method 2. Quite safe. And then, okay, by work done. So let us just put the tensions. This is T, 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 T. So this must be 2T in an ideal case. This is the same string, old string. So T, T, T. So we have to write the work done at wherever is the input and output points. So suppose you are pulling this and the output is these two or whatever. These are the points where you have the inputs and outputs. So the work done by this tension, it is moving this side by V amount, but the force is that way. So say V is the displacement, 3 is the displacement, 4 is the displacement in a second. So the tension is towards the right and the movement is towards the left. So this work by this tension is negative. So what we write over here is minus TV. This end you have 2T which is upwards and the body movement is also upwards. So what we write is plus, because they are in the same direction, 2T is the force and the movement is 3. So 2T into 3, that's the work done. For this end, again, the body is going upward, tension was also upward, so it is plus for that. So getting your minus and plus right is the key. You have to get your minuses and plus correct. So what do we get over here is tension T into 4 is the moment. I'm sorry, this is 4, so 4 is the moment. So total work done by the tension must be equal to 0. So what do we have? All T's cancels. You have minus V over here, you have plus 6 over here, you have plus 4 over there is equal to 0, gives you V is equal to 10. So the unit that was, we did work done as, these were as meters in a second. So you could have said these to be powers. So unit over here is meter per second. So that's your third method in this. And you may apply the fourth method also just to check how is the movement happening over here. So let's go on to the next question now. So what we get over here is 3, 4 and 10. Say we have called the values as X up. Since I have written up earlier, I'll just continue with that, and Y up. Then what would have been the movement? The movement would have been due to X up, this will create a 2X loose string, and due to this Y will be supplied. So we'll have 2X plus Y as the movement over here. So X was 3, so 2 into 3 is 6 plus Y 4. So you can get this very fast by just inspecting. So we'll go on to the next question now. So again, more than 2 bodies, say body 1, body 2 and body 3. So if you know the movement of 2 bodies, you can tell what is the movement of the third body. If you just know the movement of one body, you can't say how much which is moving unless until you know the masses. So, and why do I say unless until you know the masses? Because if they are a certain mass, say 2 kgs and 3 kgs, and this is whatever kgs I'm moving it with 2 meter per second. So I'll do this experiment 100 times, still the movement of both of them will be same, because it has got a certain pull from gravity and a certain release I am giving it from there. So I don't think that if I do the experiment and again very carefully, if I repeat the experiment again and again very carefully, the movements are going to be different. So when masses are given, that becomes a laws of motion question, and we have to figure out using all the forces and all that how much which will be moving. But unless until that is given, by the way, speaking of that, if all 3 are also just let go and movement of nothing is given, still you can figure out how much which is moving, and all the time it will be the same answer if the masses are known. If the masses are not known, then we need to give the movement of any two body in this case to get the movement of the third body. So take some time doing it, and at least do it by two methods, and lot of movable pulleys. You can verify this equation to get a hang of that equation also. So that's hardly required, by the way, but still. So let me analyze this for you. So my favorite spot to start is a movable pulley. If I move this by x up, what do I get? I get 2x loose string. So I'll tighten that. Nothing has moved yet. No, nothing else has moved yet. So this has gone up by x. I've got 2x loose string. So that 2x loose string, x over this side and x over that side, I'll tighten by pulling this x. So I've got 2x loose strings. So I'll pull this by 2x, and the string on this is tight. I've not moved this yet. I'm just planning how much to move. So suppose I move this also by y up. Having a loose string over here doesn't make it necessary that you have to move this body down. This can be moving anywhere. So I'll take it up so that you are not confused. Mind you, I've got a loose string of 2x till now without the movement of this body. Now I've moved it up by y amount. So what do I have is y plus y, 2y extra loose string. So how much I've got? 2x over here and y plus y, 2y over here. So this part I have to rather pull by 2x plus 2y to make everything tight again. So when I pull that up by 2x plus 2y, this part has to go down by 2x plus 2y. So what I get is the movement of this has to be 2x plus 2y. So if this moves x up, this moves y up, this goes 2x plus 2y down. I hope you can do. In the case when this would have gone down by y, then what would you have written? You would have written a 2x minus 2y. So you can practice with some numbers over there. Let me put another method to this. So what would you prefer? Increase and decrease of length. Okay, I'll write all the methods. So this reduces by x minus x. This section again, this has gone up by x amount. So this section again reduces by x. So minus x over here. This pulley has gone up by y. I don't care what has been supplied and all. I've just moved the pulley and then writing this length of the section. So your mind should not work that I've given string and hence it should fall down and all. We have to see where it has gone, and no loose strings, all tight strings. In this method too, everything is tight. So if this pulley has gone up, this section has reduced by y amount. So minus y. This section of the string has also reduced by y amount. How much is y and x? How y and x is connected is not yet known. So minus y. So the pulley has gone up. So this section has become whatever it was earlier minus y. This is also whatever earlier minus y. And this section, it has gone down, say by z amount. So this section has increased by z. So plus z is equal to 0. So what you get is z is equal to 2x plus 2y. So that's your method 2. Method 3 will be a similar thing. So this is being pulled up by T tension. The T tension goes all over the single string. So this must be 2T and this must be 2T. So it goes up by x. So the work done over here is 2Tx. This goes up by y. So it is 2Ty. Direction and displacement is same. This is T up but goes down by z. So minus Tz is equal to 0. So again we get z is equal to 2x plus 2y. And then comes a pulley equation, which is the least preferred in this case, not at all required. This movement is 0 because it is attached to the wall. This movement is what you want to figure out. I know it is 2x, but you want to figure out that, and this pulley movement is x. So what I write, how do I write the formula? X is the pulley movement is equal to one side movement, which is 0, other side movement you want to find out. So call it as, say, a divided by 2. So what you get? A is equal to 2x. So you know that this movement is 2x. So this 2x goes on. So this side of the pulley, this string is going down by 2x. This pulley is going up by y. And this is, say, b you want to find out. So what do you write? Up is, say, positive. So y is equal to, down is negative. So minus 2x is the movement this side. And that side, say, b is up. So plus b divided by 2. So what do we get over here? We get is b is equal to 2y plus 2x. So that's your b. How much ever b is supplied, this is 0. You can write the formula again, or simply this ends the question. This, if this is going up by b, this has to go down by b, and b is your 2x plus 2y. So that's your last method over there. So if I may mention this also as a method of solving, that's for you to understand how velocities work, not particularly solving the question. As you can see, these two are giving the answers much faster. Now another question for you. So have a look at these two questions and do both of them. I'll discuss both of them together later on. One is with variables. You have to find how much this moves, and if your intuition is in the right direction, say it moves by z, then put the direction also right. So unnecessarily getting a negative and then making it positive is like revealing you did not know what is happening. So you should be in full control of the situation. So guess in a very logical way where it is going, up or down, and then accordingly you do it. And if it is like it can go any which way, depending on how much is the x and y, then you can write any direction. Similarly over here, and then later on, when you have guessed that it can be any which way, if say x was way greater than y or y was way greater than x, depending on those values, then you'll put the values in your final answer and see whether your reasoning of going in the right way was correct or not. Here I've put some numbers straight away for you, so that no variables are required. You can straight away do with the numbers. So have a go at it. Let's start with this one. So I generally prefer loose strings. I've got a movable pulley. I would have preferred this going up and then studying the other movements, but it's okay since the value is given. We are going to do the way it is given. So if this pulley comes down by 4, what is going to happen? You have to have a supply of 4 and 4 string over here and there. So 4 over here, 4 over here. So where is it going to be supplied? Maybe 4 from this side, maybe 4 from that side, but it is not given it is 4. Had it been 4 up, this would also have been 4 up. Both would have gone 4 up and this would have gone 4 down. So it is similar to one other situation where you had a big pulley over here. Instead of these two ending in masses, there was a big pulley over here in this very video a little earlier. So okay, coming back to the analysis. So if I have pulled this 4 down, then I've got 4 extra string on both sides. So let us see whether anybody is supplying the string or not. So this guy is not supplying the string. This guy is in fact pulling it down. It is pulling this mass down and it is reducing the string. So who is going to supply all those string? So if this pulls down, this end is pulled down by 2, you need to have 2 going up. You have to have 2 extra string coming from somewhere. So this guy is going to do that. I've made this pulley stationary. And first I just move this body down. So this pulley is stationary. I move the body down by 2 meters and this pulley is stationary. So this has to go up by 2 meters, or stationary pulley, it has to go up by 2 meters. Now I am done with the movement of this. It has come down to its new position and it is not going to move. So with respect to the ground, it was 2 meters per second. So after 1 second it is here. So I have made that 1 second, that movement first for this. So it has come down by 2. I have made this steady over there. That is possible in a situation without any strings breaking. So I have this stationary over here. So this guy supplied. So this moved up by 2 because of this coming down by 2. Now this is stationary and we have this pulley which is now moved down by 4 meters. So if I move down by 4 meters, I have to get 4 plus 4, 8 extra string. Who is going to supply that? Now this one will not supply. Why? Because it is stationary now. So when this pulley has come down by 4, that extra 4 and 4 has to again come from here. It has to go up and it has to give. It is not like going down. So both time it went up, 2 up and 8 up. So what do I get? I get 10. So that is by analysis. By increase and decrease, this will be plus 2 this side. This has gone down by 4. So plus 4 for this section, and for this section it is again plus 4. It's the same string. It is one single string. So one single string I write in one go. And this has gone up by a certain amount, say x. So that is reduced by x is equal to 0. So what do I get? X is equal to 10. And similarly with tensions. So you'll have a 2t over here. So 2t into minus 4. Here t into minus 2, and here you'll have a t into x. So 2t into minus 4, which is minus 8t, and minus 2t, so minus 10t plus tx, you'll get x is equal to 10 again. And the last method. Okay, now coming on to this method 4, you can apply if you want. This may be one of the preferred methods for this. I mean, it is equally short as the other ones are. We analyze these three parts, so we know the velocity of two parts already. So in this situation, fortunately, in one go, once we apply that, we are going to get the answer. So this 2 was coming down, so this part is going up with 2. This part of the pulley is going down with 4. So this 2 up, this string is 2 up, this part is 4 down, and this over here is going, say this was going up with x, so this is going down with x. X is what we have to find. So we write the equation of the pulley. So pulley movement is 4, say down is positive, so down is positive, is equal to 2 is up, which is negative, x is positive, so down is positive, so plus x. Had we taken x as up, then we would have taken as minus x, but we already know which way it is moving, so we have taken plus x now. And then 2 into 4 is 8 plus 2 is 10, so you'll get x is equal to 10. So this x down will be that x up, so that will be the movement. So all methods done over here. Now going on to this question, x and y. So again, by analysis, if this is a movable pulley, I'll just go on attack on the movable pulley first. If this movable pulley goes down by a certain amount, by say a, then this would have fallen down by 2a, because you would have got loose string here and here. So if this is going up by a, this is going up by x, this would have gone up by x by 2. So x by 2 up gives a x by 2 string here and x by 2 string here to be pulled in from one end. This is tied to the wall, or this is tied to the ground, so it can't move. So this has to go up by x. So if this is x, this is x by 2. So if this part is going by x by 2 up, this part is coming down with x by 2. So if this part comes down with x by 2, now if these were equal masses and whatever, the both might not have been moving with respect to each other, so both would have gone down by x by 2, but we already know the movement of one. So if we know the movement of one, we can tell the movement of the other. So if this goes by x by 2 down, what do I have is, I have a loose string of x by 2 and x by 2 on both sides. So this, I'll just move one body down first and then fix the pulley. So this has to go down with x by 2 plus x by 2, that is equal to x. It has to go down with x. I'm just fixing this. I have not moved this. Wherever it was, I've just fixed it, and I've just moved the pulley down. So pulley has come down with x by 2. So this string just rolls over and this drops by 2x. But then this body is not fixed, it is also going up. So now I move this body. So I'll do everything one by one. It is not like simultaneously I'll do things. So once the pulley, I've put it down over here, I fix the pulley. Now I move this up. So if I move this up by y and this is fixed, then this has to go down by y. So this totally goes down with x plus y. How much ever this was, plus a y. So what we get is, if this is x and this is y, if this is x and y, this goes down with x plus y. Let us verify it by the other method, which is increase and decrease in string length. So what we have is, we have three different strings in fact. So that's your green string, that's your say blue string, and then the purple string. So there are three strings, so I would rather prefer method 3. In method 3, you don't have to write 3 equations for 3 different strings, but since I made the colors, I'll just write them off. So what happens in this method, this section, this is going up. So this green section, and the pulley goes up by a certain amount. So let me write some variables. So pulley goes up by, this is not known, so pulley goes up by a, this goes down by a, so this pulley is going down by a amount. So first the green string. In the green string, This pulley has gone up by A, so this section has increased by A, so plus A for the green string. Similarly over here, since the pulley has gone up, this section length has increased by A, but it has decreased by X. So this part has gone up by X, so minus X is equal to 0. So total increase decrease is equal to 0. So what we get is A is equal to X by 2. So we already knew that this is X by 2 by inspection. So X by 2. What we have in this blue string is, this blue string has reduced by A amount minus A over here, and this blue string has increased by A amount on that side. So plus A is equal to 0, which is a known thing. So that means how much ever it has gone up, this has gone down. Now coming to this purple string, this section, now you have to carefully see, this section has reduced by Y from this end and has reduced by A amount from that end, because the pulley has come down by A. So this section has become reduced by minus Y minus A down from there and Y up from there. Now if this goes a Z amount down, then let me write the equation of this section. This section has reduced by A from top, but from bottom it has increased by Z. So what we get over here is, your A was X by 2, so twice of A, so Z is equal to X plus Y is what you get again. And through tensions, you have, this is T over there, this becomes 2T tension in this, 2T tension in this. So this is again T, and this is again T. So T tension, T tension, T tension. So work dones are T in direction of X, Tx, T in direction of Y, Ty, T opposite to Z, minus Tz equal to 0. Again gives you the same relation. I hope with all these methods you are not going to make an error in solving. If you are not getting the same answer by all methods, then you are definitely wrong with one or wrong with both. So get your concepts right, rewatch the videos for these kind of questions.